Hello, Gophers. I'm St-Pierre, and you're listening to Go Podcast. Today, I'm joined by Jakub Jarosz, and we talk about DevOps, security, and testing. Hello, Gophers. So, I'm joined today by Jakub Jarosz, and I hope I say your name correctly. And
Perfect.
Oh, that's good. Yeah. So thank you very much for accepting this invitation.
It's my pleasure. Thank you, Dominic, for inviting me for the podcast.
Very cool. So as always, the first thing that I ask to guests is to introduce themselves. So whatever information you want to disclose, so we know you a little bit better. It could be what I typically like to hear is where are you coming from in terms of software engineering? What was your path? How did you came across Go? And what are you doing at the moment? Where are you working? So anything that you want to say us, it will be very appreciated.
So my name is Jakub. I'm based in Ireland right now. So in city Drogheda, it's 50 kilometers north of Dublin, and. In my path to software engineering is quite interesting because the background is actually the electronics and industrial automation. So that's my education was in this direction. So before moving to Ireland 20 years ago, I was mainly involved in the IT and mainly electronics and automation systems, working back in Poland many years ago. So then when I moved to Ireland, I was mainly involved in hardware business at the very beginning and later on transitioned to the test automation and software engineering slowly. So in terms of Go, actually my first time with Go was like good 7 or 8 years ago when before I joined the Salesforce almost 7 years ago. At that time, I was working for the company called Axway, and we were automating the VMware setup in the physical data center. And then with a colleague of mine, we actually decided, hey, let's use Go to create the API wrapper, right? Because before this main language that I used to work was Python and Ruby. So we were doing most of the stuff with the Python and Ansible at that time, and then it was a good opportunity to actually try the Go. So it was my first time. And then when I moved to Salesforce, that I spent 4 years, I would say that 80% of time I was writing the Go, mainly around the system security tasks. So command line applications, different parsers, small services, but the still remaining like 20-30% was Python. But it was the interesting time when the Python 3 was basically going more and more popular, and it was the final call for migration from the Python 2 to Python 3. And then with many teams, we were facing dilemma. Shall we start porting our old Python libraries and Python applications to Python 3? And in most of the cases, actually, the Python become Go. So that was like a real multi-team projects that we were porting certain applications from Python 2 directly to Go instead of moving to Python 3.
This is very interesting. I've heard that a lot. I must admit, there is a lot to impact before we start. I really like a couple of things that I want more information. So when you say hardware, I mean, I'm very curious. What are we talking about here?
In terms of Salesforce, so directly, for example, the interacting with the ILO interfaces, so provisioning, booting up machines, provisioning machines. Before this, it was mainly operation with data centers.
Okay, so this is what you were saying before you started as a software engineer. You were mainly in
yes, mainly hardware, and small writing a little bit of the scripts in Python, but mostly was the electronics, mainly writing the automation systems, a little bit of PLC programming, and automation system for the electronic scales. So I used to work in Poland in the company that we were designing and installing the electronic systems, mainly for the measuring the weight of the different devices, like production line in Coca-Cola, for example, in Łódź. So we were installing different systems and then integrating with the existing IT infrastructure, mainly networking, in order to gather the data and readings from these electronic scales to the main databases of different companies.
Very cool.
Yeah, it's quite very interesting. Very interesting.
What made you kind of switch to more software, writing more code?
That was actually the funny story, is because I moved to Ireland. I came for the 6 months English course, and the 6 months become 20 years at this moment. So after...
That's a long course.
Yes, exactly. So I decided after this half a year not to come back to Poland, but actually start my new chapter of my life back 20 years ago in Ireland. And to join the company at that time, the startup, actually, they were producing the laser machines for cutting some components. Mainly it was around the noses for the ink printers at that time. And it was Irish startup, very successful. We were sending these machines around the world for the different companies that they were producing these ink machines. And it was very interesting from this point of view that I was working mainly with hardware, but the software components were very, very big part of the entire system. So interaction between the hardware and the software, that's really what sparked my huge interest. And then gradually, because some different opportunities, as far as I remember at that time, I started moving more into actually the software, programming different test automation components for these robots that they were responsible for the lasers that they were cutting these devices.
Wow. Yeah. That sounds very, very cool. So yeah, I can imagine that at some point, if you're working a lot with the hardware and the software is controlling the hardware, it's kind of intriguing a little bit to see,
Yes.
Yeah, I can understand that.
Yes, and it's very, very interesting from the point of view that you can basically see immediately the results of your work. So you are programming something, and immediately you see how, for example, a robot behaves, if it behaves correctly or not. So it's really cool.
Yeah, there's no line that is printed to the console. Now it's a laser that shoots at something, which is nice.
Yes, yeah, exactly.
No danger.
Or some camera, for example, inspecting the wafers.
Nice.
This kind of stuff. Yeah. Back then was Visual Basic, basically. That was.
Oh yeah, the good old VB.
Yes,
yeah.
Visual Basic, and before this Visual Basic for applications.
Oh yes.
Yeah.
Yeah, this is where I started as well, but ouch. I don't really miss those days, that it was still interesting, but the dependencies I remember were kind of crazy in that environment.
Oh yes, I still remember moving a little bit between the teams when I was responsible for actually producing this software and builds, and we are using this. Don't remember right now. That was some Norton application to basically create this distribution of software. We were burning X amount of CDs that were attached and distributed later on to customers. So it was quite interesting. But comparing nowadays with current systems, it was quite laborious work.
Oh yeah, totally. Yeah. When people are complaining about NPM, because an NPM on the JavaScript ecosystem is kind of notoriously hard around dependencies, but it's nothing compared to what we had to do like in her 1998, 99, 2000. It was a little bit more difficult, and like you were saying, if you were burning CDs and for some reason there needed to be an update quickly after that. Wow,
It was really manual work at that time. I remember. I recall one time that it was some very quickly patch discovered in some C++ application that was driving some robot, and we had to quickly with colleagues reburn many numbers of the CDs and then distribute around the world.
Yeah.
Customers could actually use this new software. So I remember was shipping company was involved, so no internet.
The good old days.
Yes.
So let's turn a little bit. So you wanted to talk about Go and security. I'm very interested into that. So why Go exactly? What makes Go a good choice, you think, for attacking security problem, for example? And what are you doing with Go and security, actually?
Back in Salesforce, we were writing the different applications for example, validating the AMI roles in AWS, or the setting up the Kerberos, or different security systems. So different system needs to be glued together and provisioned, and that Go at that time, Go fit the bill very, very nicely comparing with Python at that time for the one specific reason. We were able to produce one single binary, and we didn't have problem with dependencies that we used to have. Because imagine hundreds of security people that they were involved in writing Python libraries, then different environments, different virtual environments, and we frequently spend a lot of time actually fighting these dependencies.
Yeah.
Here we were able to produce one single binary, distribute this binary, create quick installation in form of the RPM, and then the software was easy to use and ready to use without problem of dependencies. And as well, different later on, back in my current role that I work right now for the Nginx, and I focus mainly on security. As well, apart from our main product, which is the Nginx Ingress Controller, that is 100% written in Go, we are using as well the Go for writing different security checks, be this on the pipelines, for example, or for so-called DevSecOps tasks.
Right. Yeah, I've seen that a lot lately. To be frank, wasn't an acronym that I was seeing a lot? Like, I don't know, 3, maybe 4 years ago. But now these days it seems like security is exploding everywhere with good reason, for sure.
Oh yes. Definitely, like mainly the software supply chain attacks. So this is the area that we are focusing. The same like back in my previous company. So having systems that would be able to filter and validate these different dependencies that are coming to the final product, it's crucial. And especially that these different security attacks evolve very quickly. It's not even about some DDoS attacks, but actually getting some malware back to the system and then distribute the system among the different software and get the access to, for example, Kubernetes clusters. Right.
Yeah. That's a totally new, a little bit more involving than just DDoS attack. I have some question about. I'm not sure I understood correctly what the module that you're working on. So you're working at for an Nginx module, if I understand correctly. So what this module intercepts request and I don't know, validates that they are good. Is it akin to what a web application firewall is in a sense?
No, we are not working on the Nginx module itself. We are working on the Nginx Ingress Controller. So this is the piece of software that accepts the traffic from the outside and then distributes the traffic inside the cluster.
Oh.
So underneath of the Ingress controllers, they are the physical real applications. So it could be Nginx or HA proxy or many different companies. They configure their products to meet the requirements, Kubernetes requirements of Ingress controller. So there are certain rules that this software is supposed to meet, and then you can use different software in order to configure under the hood to get the traffic from outside and then distribute traffic to the services inside the Kubernetes cluster. So we are working as well in our offering. There is the WAF module, but this is completely developed by the team. Mm-hmm. But we are incorporating these capabilities by configuring our product in order to allow customers to specify, let's say, different rules in terms of the filtering traffic and verifying if there are no certain attacks.
Right.
But no, it's not. My team is not working on this product. We are integrating this product inside the ingress controller.
Okay, got it. Was there any discussion at some point? So why go for this? Was C ever in the balance, or maybe Rust? I don't know.
Probably when I joined the project 3 years ago, this project was around 3 or 4 years old.
Okay.
And I would say because of Kubernetes is written in Go, that was the natural choice to go with Go.
Yeah, sure. Well, have you seen any pitfall, any challenges that you have faced so far with this? Because I must admit that I guess that this thing needs to scale at some point, because if it's dispatching the traffic, then it needs to handle all of it first.
Like a high level challenge, I would say, not only related to the Nginx and to this product that we are working on, but I encountered in the previous company, is the challenge of bringing applications that they were born, let's say 15, 20, 10 years ago, before this Kubernetes and the cloud environments they flourished. And the workflows that basically use this old software needs to be adjusted to this very dynamic environments. Environments, by dynamic, I mean that scale up and down very, very quickly. So it's different approach to, let's say, configuring, different approach to manage, let's say, the cache between the different instances. So it's like a constant, regardless of the product, it's the headache, how to fit installation, for example, of the product that, let's say 10 years ago, we were using VMs or bare metal servers. We could have some high availability system configure on the Linux level, let's say having, I don't know, X number of machines, and then handle traffic in this setup versus moving this different configuration that was done in the physical world to pod levels, put everything inside containers and make sure that more or less the same mechanism work right now in the cloud native environments.
Right.
So this is challenge. I remember like old Java application, not in this company, but old Java application, as well the API gateway that this application were shipped to customers as appliances. And suddenly customers started asking, can we run this in AWS? Can we run this in the Kubernetes cluster? And then because the nature of these applications that they were, let's say, installed manually, they were reading in many stages different configuration files. They were not so easy automatically, let's say, scale up and down. That was huge challenges to put them and fit them inside the Docker images and make sure that actually they behave in the cloud native environment correctly. Not only treat the Docker image as another VM or the clone of your server.
Right. And I guess also the challenge is to not have to touch any line of code of those legacy application because let's face it, almost nobody wants to touch them anymore.
Yes, exactly. But even though the way how these applications are configured sometimes has the huge impact on the workflow or the amount of work that would be required to adjust them to, let's say, dynamic environments running in Kubernetes.
Right. Yeah. It makes sense when you think about that. I mean, it was I kind of lived something like that because I first let's say that the system was on-prem even, and now the lift and shift is kind of very, very hard to accomplish, to be frank.
As long as, let's say, this lift and shift is done in the way that you are not changing any setup, but the nature of Kubernetes is basically to be dynamic and allow users to scale applications up in order to, let's say, fulfill some traffic requirements or the amount of load that is coming in, and then automatically scale down. So this is like truly dynamic way of handling
totally.
the environments. And on the other hand, they allow customers to, in theory, save money of not using the amount of resources that they would potentially be using with this application having the, let's say, physical servers.
Right. So you're using Go for automation. Can you give us some example of what I don't know what you find comfortable to use Go for automating, I guess, tools and tasks?
So we are using the Go for writing the ingress controller. So basically, this is I would describe this as the application that takes Kubernetes native the objects and then perform different validation, and then at the very end assemble the final Nginx configuration file from these pieces of the Kubernetes native objects. So this is quite interesting the area where you would need to deal with the native objects, apply special validation, and on the other hand, make sure that the all rules that Nginx itself require from the configuration files, not only syntax, but the business rules between, let's say, different virtual servers or different other components are met. Otherwise, we would be getting error because the Nginx basically wouldn't start correctly. So this is the main challenging point, not only for Nginx, but for every single company that writes and develop the ingress controllers, based on specification from the Kubernetes, and then getting this specification to basically create the pieces of configuration for the product. Either be this Nginx or HA proxy or any other the web server that or the proxy that is responsible for getting the traffic, apply certain rules, and then forward this traffic back to the cluster, inside the cluster.
I would imagine that this is kind of very hard to test. I mean, how do you ensure you were talking about security earlier? I mean, is this a challenge to test this entire system?
They are challenges. Standard, of course, when you write the Go code, the standard is that you have your own the tests written in Go. They can be on the very different levels. So I'm talking right now about this standard unit tests for the, let's say, your different methods or functions, just to make sure that everything is working correctly. But as well, the main challenge is that in many cases, in order to simulate the behavior of the Kubernetes, we would need to write extensive mocks. There are some frameworks written by the community to simulate certain behavior, but at the end, when I look through the amount of work required in order to mimic some behavior, sometimes it's easier to write the high-level tests using, for example, the test containers that we spin up like one node the cluster, and then simulate the user interaction through the API,
Right.
and then verify if certain components are created. So I found that this, in many cases, it's much less work to do this. You interact with the real cluster and then perform the validation of correctly created objects, for example, of behavior, versus having very, very extensive the setup of preconditions and then ending up with a lot of mocks that could behave differently based on configuration. So we have like, I would say, 2 levels of testing: normal unit test for configuration, for validators, and then the higher level tests where we spin up the cluster and then perform the tests. And then another third layer that we have, like a final integration test, we have the Python framework written to simulate as well the user interactions.
Interesting. So when you say the Python framework, it's because there's 2 languages to interact with this?
That's the historical reasons. When I joined company, it was already this framework was in place. I know that the different teams and different companies that they work on with the Go and Kubernetes, the ingress controller, they have both the layer of tests written in Go. This project, the test containers, it helps a lot because it's basically simulates. You can quickly simulate you can create the real one node cluster and then simulate the user actions with very few lines of the Go code.
Right. Yeah. I can imagine that it's more easy to do that way. I can see that. You had a lot to learn to when you say you're there since 3 years. So were you already all familiar with everything that you're working on at the moment? Was there a lot to learn?
It is still. There are some dark corners of Kubernetes that basically it still require to learn, and especially that it's not only software itself, but the new features that they are being added to Kubernetes that customers are asking how to use the product in their setup. So there is no way you achieve
Right.
some stage that you would say, I mastered this. So this requires still constant refactoring or the making sure that these new features, they are coming to Kubernetes, which is basically released every 3 months and is very, very dynamic environment. We are still basically are up to speed and are able not to even only write our Go code and adjust to the changes, but as well to answer our customers' questions.
Yeah. Are you using TDD to handle those new features? How are you handling the development of that?
Yes. So myself, coming from the QA and test automation background for years, for me, actually, the reading test first is the perfect way and way to go to learn about the system. When I see the clear tests and clearly described the action preconditions, I don't usually need the documentation. Mm-hmm. Assuming that these tests are written in the way that you can figure out what kind of the behavior of the system developer, for example, wanted to test, or document behavior by using certain tests. So myself, I use test-driven development. So first I think about, okay, what kind of the behavior I want to implement. Then I write the test, then I write code. And this is like, we know the cycle, red, green refactor.
Yeah.
So if I don't know what I really want from the system, for me, it's quite impossible to imagine how I can start writing something unless I'm like hacking a little bit and checking on the, let's say, developing main function or some functions and hacking a little bit. But when I have like a broad idea what I really want, I need to be able to express this behavior in a test. I need to know what the system should be in the beginning of the state, what my, let's say, functionality developed should change in the system, and I need to know how the system should behave after this change. So, and knowing this answers to these three questions, it's all what it takes to write failing tests at the very beginning, then fulfill these tests with the writing software that meets this criteria, and then see this test pass. And it's like a small step-by-step cycle that allows me to model behavior, making sure that behavior is covered with tests, and then move to the next step.
Yeah, I found this is the challenge with any kind of test, especially with TDD. Just knowing, like you are saying, knowing what the system is, what it should do exactly and how should it behave. This is the challenge, and sometimes it's not clear at all, and you're starting to do your test, and at some point you realize that, wow, this behavior is not going to work. So now you need to change all the tests as well. So it's a pretty hard thing to do right, I believe. When you know exactly, I was doing my last episode on tests. So when you're knowing exactly what you need to do, this is great, this is perfect. But yes, exactly. When there's a doubt or anything that is unclear about the system, are you finding that doing TDD help you refine your initial thoughts or your initial understanding of the system or what you need to build? Is it helping you at all?
Definitely. And the problem that you mentioned, that let's say you change mind or you figure out that you need to change a little bit behavior, and then you end up, let's say, for half a day changing your failing tests. So this could be the reason that many people maybe they focus not on the testing behavior. Be this, let's say, in Golang, it would be exported function or exported methods. But a lot of maybe effort is put into writing this very small tests per function each, not exported functions. So I usually start, let's say, when I start writing some function or thinking about some function, even not exported, I write the test. Then when at some point this small not exported function would be a part of some exported behavior, I usually delete the small tests as soon as I have covered this with the larger test that checks the behavior of the system. That is, trigger this behavior by exported method or exported function. So this case, my tests evolve when I'm not keeping the small tests that test the separate functions, but I keep later on only this test that execute and give me the answer if the behavior of the system that I could trigger using some public API for my package through the exported function is correct.
I like that a lot, I must admit. This is pretty good, pretty interesting. Have you seen that when you are deleting those tests, are you is it helping you shaping the architecture of your code at some point, but making sure that you're keeping your function short and things like that, is it helping you in designing the code at all?
It helps, but I must say that when I do this transition from the, let's say, when I remove small tests for these not exported functions, I'm thinking about, okay, what kind of the table tests I will create for exported function, and I keep an eye every time on the test coverage. Did, for example, this behavior that was at the very beginning exposed by the small function is covered with my, let's say, table tests that I use to inject certain data to this exported function. So then when I see, okay, this is covered, I can remove the small tests because there is no point to keep the same test for the same behavior. And just in case, even to, as you mentioned, if something changed, I would need to have, let's say, 20 small functions that anyway, that they have the tests that already larger tests for the large exported function covers. So this is like constant refactoring of the code and thinking about, do I have the test coverage? How this function should just in case fail, under what kind of the input data? And in the same time, thinking what kind of tests are already obsolete and I can remove them because behavior is already tested in my different test.
I like that. Is your testing mentality is from a long time ago? Because we were talking about VB at some point. There were no tests. There was not even a test suite coming with Visual Basic at the time. So when have you started to?
That was actually a funny story. The testing mentality, I would say, started when I was like maybe 8 or 9 years old, when my father bought me the first electronics, like blocks for playing with electronics.
Nice.
And I basically mix up batteries, and instead of connecting 3 volts, I believe I connected 9 volt, and at that time system basically crashed in terms of this one of the circuit got burnt. I only felt a little bit of smell of the burning. and unfortunately it was not something that could be replaced very easily, because it was the imported at that time that was the time before actually we were behind the Iron Curtain during the communist time. So it was quite tricky to get this particular circuit, but my father managed this. So since that time, I always had a basically hard lesson, always to put the multimeter to figure out if I really need this particular voltage to these particular places, and then transferring from the hardware, of course, to software, right? If I really have something that is useful to test particular behavior. So this mindset comes from interacting with hardware, that you can damage something, and it's not so easy repairable, like, let's say, piece of software that you can change a couple of lines.
Yeah, I like that. I like this story a lot. I imagine a couple of software engineers that do not really do tests, and if their codes were to burn at some point, it's because there's a bug in there. So not only there's a bug in the system, but the source code is damaging. Yeah. That would be
that was common bug. I remember back in the ZX Spectrum when I actually attended first the programming course with basics. I remember the issue that first we needed to connect the power supply to ZX Spectrum, then to the socket. Otherwise, that could be a sparkle that basically would burn the motherboard. And I managed to do this once.
So
yes.
You are pretty dangerous as a boy, right?
Yes. Yeah.
That's very funny. What about, let's discuss that, because I mean, I find that the test subject very interesting to me at least. What about when you are jumping into some code and there's not much test? Is what is your reaction then? Because let's face it, everyone is saying that everywhere on the internet. It's always, you always read the sentence like, I started working on that code base and nobody really trusts the test suite. It's a little bit less and less true these days, but it's still happening. So what are you doing?
Oh, that's an unfortunate situation, but My first thought is you are a little bit paralyzed when you try to change something. And I would say, I remember this time, but then back then working with Python. So basically I spent countless of days with the PDB, Python debugger, to figure out how the values of particular variables change. And then based on these discoveries, we were with a couple of colleagues trying to write the tests for this particular behavior. But in general, it's very risky business start refactoring or changing this particular software when we don't have test coverage. So I would first actually start thinking about writing some higher level tests to wrap larger behavior, and then started experimenting and reading through the code, start noticing maybe certain patterns, and then extracting this behavior into separate tests and then separate functions.
Right.
Otherwise, it's hard a little bit. I'm just looking through the history. I remember this kind of problem that we started doing some refactoring back then with the Python code many years ago, and it happens that for whatever reason the order of some values in XML files, as far as I remember, changed, and it broke for some functionality, but it shouldn't in theory, right? Because when the XML was basically parsed into the data, it shouldn't matter. But at that time, I remember some problems related to this, and the nightmares and time wasted spent on this refactoring and trying to figure out why something is not working and trying to change something without the tests, and it was always like praying time,
Right.
which is not a great approach.
No, for sure. Have you noticed that in the Go teams that you were part of, the tests were kind of, at least minimally always required for any new development and things like that?
Maybe not. We have very good, I would say, the test coverage. The problem that I see with tests, not only in my company, right, but in the different code bases, is that people who write these tests, they don't use descriptive names. What kind of the behavior is tested? And everything is okay until we have in our mind this piece of functionality that we are working on. But even though next week I would need to, if I don't describe the tests in the, let's say, some sentence that would describe behavior, even though the name of the test would be longer, but instead of saying test ABC or test name of the function SBC, and then I have, for example, 20 or 30 different inputs, some of them make the test pass, some of them make the test fail. When someone new is jumping to the code base, and especially when it's new to the domain, there is no way that he could figure out, okay, what this data input, why this data input make this test fail, make this function behave incorrectly. And then it involves digging into documentation, which frequently is not up to date, talking with people, assuming that people who wrote this are still on the team. If they are already left either company or they are moved to the different team, then it becomes the problem with creating the mental model of the functionality of the system. That's the reason I'm big supporter of idea of writing the comments, but not comments or documentation, the documents for the functions and for methods, not to describe what the function does, because everybody can read who writes, let's say, Go code. But when there is some underlying the context, describe why, for example, certain approach were used. to give the broader context. So then I don't need frequently official documentation for the code, because usually this kind of quirky details are not documented. But when I read the code and I see this needs to be done this way because of this kind of bug somewhere, right? So you can spot this even comments into the standard library in Go. It gives you the ability to create very fast the mental model why something is done. So the answer, in my opinion, for the question why, it's more important than what we are doing.
Yeah, totally. This is a sane approach to have in the comments. So you were going to say?
Yes. No. This as well is in situations that you have some functions that take, let's say, as arguments some structs, and many times these structs are quite large. And for example, this function is supposed to fail in your test suite because of some invalid value of the one field in your struct. You have, let's say, 30 fields in the struct. If you don't have documentation what makes the struct incorrect and why, it's quite hard to figure out. So then when I write the comment that, for example, the value, I don't know, let's say 520 kilobytes when I put here in the configuration versus 256, this is incorrect because of something. For me, when I write this kind of software, it would be a matter to spend additional minute to add one line. For the new colleagues that they are coming to the code base, or for the external contributors to the open source software, this is like godsend, I would say, at least for myself. When I read code with the information why something is done, what's the reason, then it becomes much, much clearer and allows to basically focus on your work, which is, let's say, develop new functionality or fix the bug much, much faster.
Oh, yeah. Yeah, totally. And you don't do that inside a function. So let's say in its implementation itself, there's something, very particular about something. So you are not tending to put an explanation comment there related to, either the business logic or something related to the domain. So you are not doing any in implementation comment.
Inside the function, sometimes yes. But we have in Go great parser for our documentation and our functions. We can embed the links to some, let's say, the external sources. So generated documentation for the Go package, it's really brilliant, and we can really use all these features. That is actually documented on the Go dev page, how this doc strings should be structured and what kind of information we can add them. And I would say that spending additional few minutes is basically very, very valuable for other developers.
Oh yeah.
Or potential contributors, especially for the open source projects.
Right. Yeah. Oh yeah, totally. Have you had difficulties balancing between the pressure of releasing something and the need to write either this documentation or the test itself? So how do you balance that?
Main focus is on quality, right? Yeah. I don't like skipping. We are all under the pressure. And I was a couple of times in the history of working in different companies, up to the one point that we made basically within one pressing one enter key, I managed to delete one database. Thanks God it was test database, right? Because we were under pressure. I've seen wiping out 1.6 thousands of the virtual machines with CentOS in one company.
Wow.
Because of the lack of basically tests and the pressure. And then it resulted with the multiple teams with our colleagues in Hyderabad working 24 hours, trying to basically resume this VMs because we didn't have certain tests, or tests were not done for the Puppet code that pushed changes. So that reminds me one joke that the DevOps is like, let's break the servers 1,000 at a time. So I remember we were this kind of jokes in the community.
Nice.
So this is real. Sometimes it's real problems because quality is the paramount, right? So it's very easy to make the very simple. I wouldn't say simple. Some mistake that otherwise could be avoided because of the stress of the pushing the pressure that we need to, let's say, fulfill certain the timeline or requirements. But then possible the disaster that could happen, it's much larger. So it's the blessing if the teams have directors and managers who actually support this approach towards quality. And it reminds me one of the training that I attended years ago in Dublin in person. The Uncle Bob was here with clean code, and his approach towards the professionalism and approach towards the engineering. And this very famous, his quote is over the internet, that QA team should find nothing, and another, we will not ship shit.
Nice, I like that.
So under any circumstances, pressure, we should not, let's say, ship the software when we feel that we are not sure about untested some behavior or some corners that are not verified.
Yeah. AI will help us clean everything else.
Yes. That's another very hot topic, right? On the other hand, yes, unless it will create the future arms of so-called 100 times ninja developers who will be able to fix all these different bugs created automatically by AI. So they are different views.
Yeah, totally. So maybe in conclusion, I'd like to hear your thoughts about, you were mentioning that you were finding that potentially Go could be a good first language, or maybe not. I'm not sure about your opinion about that. So
it could be. The matter is to find the proper approach to introduce to the language, not even to the language, but to the idea of automating certain tasks. Because this is software for. We are using software to automate some tasks, some processes. So if this is done correctly from the education perspective, I wouldn't say that Go is not, for example, it would be worse or from Python or something like this, because I seen on internet this kind of the discussions. But I would say yes, definitely can be, and there are many books that they prove that can be with the proper approach, like the books from the John Arundel about the For the Love of Go. Brilliant approach for people who even they are not tech savvy, but his education approach basically allows people to create the mental model in their head and connect the physical world with actually this a little bit less world of writing software, which is the less physical. We can't touch this, so sometimes it's harder to understand, and harder to figure out and imagine, right? What's going on. So if we use the proper analogies and proper descriptions that would allow to create this mental model in the heads of the newcomers to programming, all obstacles can be basically removed.
Right. Yeah. Yeah, I hear you on that for sure. It's it's a difficult difficult topic. I feel like, yeah, I mean, maybe the language is almost not really a matter of concerns for newcomers, especially these days. I mean, learning a new language never have been so easy where we are at the moment. So yeah, the concept and having a solid basis is way more valuable.
And regardless of the age. So I would say if someone is in 50s or 60s, still is working and it requires his work some automation approaches, there is no reason that this person can't, for example, to figure out and learn how to do this, versus someone in the elementary school that, let's say, is tinkering with the Raspberry Pi or with Arduino from the age of 5 or 6. And using some, let's say, Scratch environment to figure out even some basic algorithmic thinking.
Oh yeah, totally.
So nice. Definitely Go, I would say it's would be suitable as a first programming language, definitely.
Yeah, I really like the reading others' code in Go. For me, especially as a blind person, it's so standardized, and I don't know, it just feels how can I say that, like I've been here before. If I enter into someone else's code, it's like, oh yeah, you know what, I'm comfortable here. I know what's going on. I understand what's going on. There's no magic. That's what I like about Go.
You touches this very important point that we don't need to spend in Go time. I wouldn't say arguing, but discussing. Okay, shall I use, for example, this naming or this space, or how to structure this code?
Yeah,
we have one Go FMT font, and there is no problem with communication and reading, right? And figuring out that someone would wrote similar functionality in a different way, and you need to spend time to trying to figure out what this another person tried to convey through this code. As you say, you just look at the code, read the code, and you have immediately feeling what is doing.
Yeah. Oh yeah, totally. It doesn't really do that in other languages that I've came across. To be frank, there's always, well, yeah, one can say that Go might not be as expressive as something else, but yes, on the other hand, it really helps readability for the code.
Yeah, simplicity and readability, easy to understand, easy to basically understand what's going on. And in a standard way.
Yeah.
You log into the standard library, then you look into some different packages, and functionality is expressed almost in the same way.
Yeah. What are you looking for? Let's have a closing thoughts here. What are you looking for the future? Is there anything that is coming to Go, or that you would like to see coming? What are you looking for?
I don't have, to be honest, such desires.
Yeah.
Current version of Go has everything that I really need to describe and express the behavior of the system that I'm working with. In my personal project as well, I have what I have in Go, and I'm really happy, and I rather concentrate on digging deeper into, let's say, fundamentals or the other technologies that they are coming, like the WebAssembly, for example, versus arguing, oh, do I have generic and how it's, or do I don't have generics, and this kind of discussions. For me, to be honest, doesn't really matter. As long as I can write and read clean code and solve the business problems or my problems in this particular language in the simpler way, I don't have any desires. What should come first?
Oh yeah, I'm totally with you on that, and I've said that earlier in this podcast. I will say that again. In my opinion, even the cadence that they are releasing, and I would slow that down a little bit. I would do not more than one update per year, and just do some security update and things like that. We don't need that language to go that fast. It's not C#, it's not Java.
And not Python as well.
Yeah, totally. Yeah.
Especially nowadays, I have opportunity to dig deeper into the Python, and basically many constructs I need to look up the documentation, because I'm just, what is this?
Oh yeah. Oh yeah, I hear you. I'm a little bit on Python these days as well for monetary reason, but yeah, it's interesting sometimes. Thank you so much, Jakub. So, do you have any I don't know, resources or closing message that you want to say to the listeners?
Don't be afraid to dig into the standard library and learn from there as well, especially the constructs. For the newcomers, definitely John's books.
Oh yeah,
that's really, I would say, even godsend. This approach, the education approach, and spend at least 15-20 minutes daily reading the Go code in standard library. We read not enough versus writing. So reading the standard library, the code, it's really good source of learning material.
Yeah, I agree totally. So go clone the Go repo and
yes,
pick a package per week and read that.
Go is written in Go, exactly. It's easy to clone a repository from the GitHub. Go to the SRC. We have packages, everything. We can read. We can see the patterns, how these certain constructs they approach. And what is interesting, just to closing the remark, when we look how the standard library is constructed and how the Go developers approach the problems, then we can, when we start using the same patterns in our Go code, when we are running or the debugging code or even reading, doesn't matter what IDE or editor we are using, then we don't need to mentally switch between the different ways of the approaching certain constructs. When I write the Go way of solving the problems, then when I go to the standard library and I need to read documentation for certain function, basically the code is the same. If I see the Go code written more like JavaScript, right, it would require already mental a little bit the juggling.
Right.
In the head. So read standard library.
Absolutely, totally. That's a good advice.
People don't need to understand. It's a matter of getting familiar with syntax.
Yeah, absolutely. All right. Thank you. Thank you so much. It was fun.
Thank you very much, Dominic, for having me. It was great fun.
All right. Let's talk later. All right, that's it for this week. I would really appreciate if you can talk or share about this podcast. It's always helpful. Also, another way to support this show is by purchasing my course. There's always a link in the show notes. So on that, see you next week.